Hello! In this tutorial we will be learning how to find the nearest enemy within a radius using interfaces in Unity. The script we will be creating will allow the player's character to target the closest enemy and change its color. So, let's get started. I have already prepped the scene by using a simple plane as the ground and a few capsules as the player. The player will be using the character controller component, and I have already created a very simple character movement script. Here it is so you can check it out. Besides that, inside the main camera I have created another script called camera follow player that basically just follows the player around as he is moving. Great. Okay, so let's get started by right-clicking and creating a new C# script called find target. I'll capitalize that. Great. Also, we need to create our interface, so create C# script iTarget. So interfaces. Now, the simplest explanation I can give is that an interface is a set of rules or guidelines that define the behavior of an object. It is a contract that specifies what methods and properties an object must have, but it does not provide an implementation for them. In other words, it defines what an object can do, but not how it does it. Interfaces are useful in situations where multiple objects need to share common functionality. Instead of having to write the same code for each object, you can create an interface that defines the shared functionality and have each object implement that interface and that functionality. So let's create that into an interface by removing the mono behavior. Silly me, down. And change it from class to interface. This backwards. So we don't need the start and update methods. And in our case scenario, we want to use two functions. One is void target, and one is void untarget. Now, the target function will actually change the enemy's color when it's been registered as the closest enemy, and the untarget one will set back to its default color. So let's go back to our script, remove our comments, and let's start writing it. So let's start by declaring a public float called search radius and give it a value of 10. What this does is determines the radius around the game object, our player, that the script will search for targets within. We also need a reference to our interface called closest enemy. This will store the reference to the closest enemy found. Let's remove the start and make our method. So void find in area. It should do it. We start by declaring a local integer called max colliders. Set it to a value of 5. This determines the maximum number of colliders that the script will check for targets. We also need the collider array called hit colliders, which we will set into a new collider array with a length of max colliders. Moving on, we need to do int num colliders, and we will be using the physics system of Unity. So physics.overlap sphere non-alloc. Now what this does is this is used to check for colliders within a given, sorry about that. What this does is that it's used to check for colliders within a given radius around a specific point in Unity. But it doesn't allocate memory for a new array every time it's called. Instead, it fills an existing array that we passed to it as a parameter. It's useful for when we are calling this function multiple times and want to avoid the memory allocation and garbage collection that comes with creating an array every time. This is more performant than physics overlap sphere because it doesn't actually generate that much garbage and it doesn't stutter our game, And in our case, we are going to be using this because we will be running that method inside our update method. So let's move on. Now, overlap sphere takes a few parameters. The first one is the center point, so transform position, because we want to cast that sphere from our player. We want to give it a radius of our search radius variable, and the colliders that we want to check are the hit colliders. Now, after that, we also need a float called closest distance, which we will be setting to mathf.infinity, which is a large positive value, and we will use that to keep track of the closest distance to the target found so far. Moving on, we need a for loop to iterate through them, so for number of colliders, we need to check target. Right now we're passing a reference to our interface, so as it iterates through them, for each collider it checks, we need to do a hit colliders I dot try get component out target. So as it's iterating and hitting colliders, Unity is trying to get the component. Does it have a target interface? If it does, so if target is not equal to null, we then check our distance. So float distance is equal to vector3 dot distance are 2 points, because this one calculates the distance between A and B. Our first point is, you guessed it, our transform dot position. And our second is our hit colliders, I, since we are looping through them, transform position. So if the distance is less than the closest distance, if we don't have a previous enemy, if closest enemy is not equal to null, we need closest enemy dot untarget. So we will revert back to its default color. If by any means we don't have any previous enemy, we need to set it. So closest enemy is equal to the target. Then we set closest distance equal to distance. So we're updating the value of closest distance with the current distance. This way we can always compare the distance of the current collider to the closest distance that has been found so far. That means that when our script finds a collider with a distance that is less than the current closest distance, it updates the closest enemy variable to the current collider iTarget component and updates the closest distance variable to the current distance, so that the script can check if the next collider is close or not. And when we do find that, we do closest enemy dot target. So we found one, we set our distances, and we set this as the current one being targeted, so change its color. Let's do a simple debug also. Closest enemy is closest enemy. Great, let's save our script, minimize it, and let's create now our enemy class. So enemy. Let's open it up. Remove the comments. Remove the update method. And let's get it to use the iTarget interface. Simply like this. You'll see that it's red because we aren't actually implementing the interface. So we can do our implement interface, remove the exceptions, and let's start working on it. So our enemies need two things. One is a private renderer called rend, and the color. Let's call it default color. And let's get those components. So in our start method, we will do rend equals get component renderer. And our deval color, the initial color that the enemy has, is deval color equals rend.material.color. Now, when we do target it, we need to do rend.material.color is equal to the color blue. And when we untarget it, we need to set the rend.material.color back to the default color. Pretty simple, right? So let's minimize that. Give it a second to compile. Great. Let's add our enemy component into our enemies. And let's add our find target into our player. Save our project again and hit play. So we're moving around, and as you can see, when we reach an enemy, we change its color. Pretty simple, right? It always updates what the closest distance is. That way we can always target the closest enemy in range. We can also increase the value, so it will search in a bigger area. So thank you for watching. I hope you learned a bit about interfaces. If you like this video, please hit like and have a great day.